And we'll do another attempt. Okay, so I feel like we started pretty well at the beginning. We circled this 2 by 2, and then we circled this third column and this second row, and then now again we're trying to keep the biggest pieces possible to cover all the ones. Currently we have these 2 ones that are uncovered. Remember that we have this wraparound effect, right? So if I look here and here, I have a 2 by 2 that I could have circled. So I'm going to circle that now in this goldenrod color. So that last one is a 2 by 2 using this wraparound effect. Now let's write down what we get. So now we have 4 pieces, which is better than the 5 we had a moment ago. So there's definitely improvement there. Let's write down what we have. So again, the green is, let's see, it's going to be W bar Z. W bar Z. So we have W bar Z plus the pink, which is YZ, plus the purple, which is going to be W bar X. And finally, we have this last 2 by 2, which, what's that? Let's see. Okay, so in this last 2 by 2, the wraparound 2 by 2, we have both types of W, so we leave it out. And we have both types of Y, so we leave Y out. This means we have X, Z bar. X, Z bar is the last term. And just as a reminder, this last term that we got now in this second attempt, it used to be XY plus XY bar Z bar. And it's not obvious that you can simplify xy plus xy bar z bar into xz bar. Probably you could figure it out with the properties, but what's nice is using this strategy we're talking about with the K-map is what allows you to do that simplification, because you're using the Boolean algebra properties in the background with the way you're doing the covering of ones with these big pieces. So to sum up, what principles did we use for the K-map? We had groups of 2, 4, 8, 16 cells in a rectangular formation. And when I say that, I'm talking about the 1 by 2, 2 by 1, 1 by 4. If you have a 4 by 1 or a 2 by 2, you might even in some cases get a 4 by 2 or a 2 by 4 or a 4 by 4. It depends on the number of variables you have. Then you can reduce using, in the background, you're using the distributive law, the unit property, and the identity law, and probably also commutative and associative properties. But the point is that this strategy we're talking about with the K-map allows you to use those properties in a way where you're not painstakingly having to show lots of steps. You're just trying to cover all of the ones with the largest pieces possible, where overlaps are allowed, but leave out the unnecessary overlaps. So this is the idea behind using a K-map to reduce a Boolean expression, which, as we saw earlier, if we reduce the Boolean expression, that means the logic circuit will be much simpler looking.